In this video, we are going to see how to convert a normal distribution into standard normal and some questions related to z-score. Any question on normal distribution will have a value for mu, it will have a value for sigma, and for the standard normal distribution, it is necessary that mu equals to 0 and sigma equals to 1. So whenever we are converting a normal distribution into standard normal distribution, then only we can use the table, which is standard normal distribution table, for finding the probabilities, that is area, or finding z-scores. Otherwise, if we are using the calculator, online calculator, we don't need to do those conversion because that calculator has the facility to plug in the values for mean and standard deviation. So this is the rule which converts normal distribution into standard normal, and this z is also known as z-score. Let's look at some examples based on it. Former ISU basketball player Kelvin Cato is 83 inches tall. Assuming that the heights follow approximately a normal distribution with the mean of 70 and standard deviation of 3, what is the z-score corresponding to it? Now the formula for z-score is x minus mu divided by sigma. So the value of x is given as 83 minus value of mu is 70 and sigma is 3, which is equal to 4.3. Now if we locate this 4.3 on standard normal distribution curve, then we can see that this 4.3 is somewhere over here, which is above or outside the range of 3 and minus 3. So I can also say that the area which is between mu minus 3 sigma and mu plus 3 sigma, within 3 standard deviation, 99.7% of the data is distributed. As we know, this 4.3 z-score is lying outside this region. So this 4.3 z-score is belonging to the remaining 0.3%. So that's why what portion of the men are taller than him? So approximately 0.3% of the people will be taller than him. Going back to the next question. For this standard normal distribution curve, we need to put the values of the marked value. We have to assign these names. Mu is given as 60, mean is 60 and the standard deviation is 6. This value is mu plus sigma, mu plus 2 sigma. This is going to be mu minus sigma and mu minus 2 sigma. This is 60 plus 6, which is equal to 66. This is going to be 60 plus 2 times 6. So 60 times 12, so 72. This is, we have 60 minus 6, which is equal to 54. 60 minus 2 times 6, so 48. So this is the distribution in the normal distribution, or distribution of the data or the values in the normal distribution. Looking at this question now. If Sarah scored 78 on her history test, which had a mean of 70 and a standard deviation of 3, and she scored 84 in her math test, which has a mean of 80 and standard deviation of 2, on which test she scored better? Now finding z-score, whenever we are comparing two quantities, then we should always compare and look at the z-scores. We have calculated the z-score for history and the z-score for math, so we can make out from comparing the values, then in history the performance is better as compared to math because it corresponds to more value of z-score. In the accompanying diagram, the shaded area represents approximately 95% of the scores. If these scores are ranged from 78 to 92, what is the mean and standard deviation of the data? We know within 2 standard deviation, 95% of the data is distributed. So 92 minus 78, which is equal to the difference of mu plus 2 sigma minus mu minus 2 sigma. So 14 equals to 2 plus 2, 4 sigma. This is going to be 4 sigma divided by 4. So value of sigma equals to 3.5. So this is the value of sigma now. So we calculated the standard deviation for this question, which is equal to 3.5. Now our aim is to find the value of mean. To find the mean, we know mu minus 2 sigma equals 78. Mu equals to 78 plus 2 sigma. So equals to 78 plus 2 times. Sigma is 3.5 times. So 78 plus 7 gives us 78. This is going to be 78 plus 7, so 85. So the value of x on the mu for the given question will be equal to value of mean is going to be 85 for the given question. So this is how, depending on the criteria or the information provided in the question related to Z-score, we can solve these questions. Thank you.